Okay, so let's do a couple more examples. So example 2. And we're taking derivative of x plus 3y. So d dx, x plus 3y. And yeah, so derivative of x is just 1. So that's 1. Derivative of 3y. So we're treating that y just as a regular variable. So there's going to be derivative of 3y is just 3. And now that inside is y, right? So just dy dx. Okay, so that was example 2. Example 3. Example 3 is a little more difficult, and you guys can pause the video and try to do it on your own. So it's x times y squared. Okay, so we have right. So we have two functions, right, multiplied by each other. So it's gonna be product rule, right? So derivative of the first one, and then the second one unchanged, right, etc., etc. Okay, so let's do it. So derivative of the first one, and maybe I'll do it like this. I'll do it slowly. So x, right? So I'm taking derivative of that x times y squared unchanged. Now I have x unchanged and derivative of y squared. Okay, so derivative of x is just 1. Let me write it here. So we have 1, and then I wonder if I can move it like this. Maybe not. Okay, so derivative of x is 1, and now the second function is unchanged, so y squared. Now the first function is unchanged, so x, and derivative of y squared. So that's going to be, right, that outside is that exponent 2, so it's going to be 2y. And now derivative times derivative of the inside, so that's just y, so dy dx. Okay, so that basically is it. Let me just simplify it a little bit. So we could factor out y, but it's not, we could, right, factor out that y, but it's not going to make it any simpler. So I'm just going to leave it like this. So now 2x y, and now I'm just going to write y prime, right? So that's y prime is that dy dx. Okay, so that's the final answer. And now, right, so we have this ability of differentiating the implicitly defined functions. So let's go back to that example with the circle. Okay, so example 4. And we'll try to calculate the slope at a point that's on that, right? So when we were initially, right, when we were doing that derivative, let me write that equation of the circle. So x squared plus y squared equals 25. Okay, so initially we had something like this, right? So y equals square root of 25 minus x squared. So in this case, right, I'm just looking at the right upper half of that circle. Right, so that's the reason why I cannot take a derivative of the points that lie on the bottom half. Okay, so now we have this new skill, right? We acquire the skill of differentiating the functions that are defined implicitly. So yeah, let's use that skill and figure out what that formula for slope will be. Okay, so taking derivative with respect to x of this whole thing. So x squared plus y squared. And now on the right side, right, similarly, derivative with respect to x, 25. Okay, so on the left side, I'm taking derivative of that x squared first, right, and then derivative of that y squared. Right, so we have derivative of x squared is 2x. Now derivative of y squared is 2y. Right, so we have that 2y. And now derivative of the inside is dy dx. dy dx. Okay, derivative of the constant of a number is 0. Let's just divide everything by 2. Okay, so we have x plus y dy dx and 0 here. Okay, so now we'll solve it for the dy dx. I'll do it slowly. So we'll have, right, so I'm subtracting x from both sides. So minus x. So I get y times dy dx equals negative x. Right, and our goal here is to, right, to solve for that dy dx. Okay, so our goal is to find the derivative or slope, right, at, let's do that point 3 on that bottom half of the circle, right, so 3, negative 4. Okay, so to find the derivative of that point, or the slope at that point, I need to have this equation solved for dy dx. Okay, so let's do that. So I'm dividing by y, so I get dy dx. Okay, equals negative. Let's put that negative up there. Actually, doesn't matter. But so we have negative x, and I divide it by y, so it's y. So this is the, right, this is the formula for slope, or for finding derivative at any point. So let's use it, right? Let's use it for our point. The point is 3, negative 4. All right, so I'm going to write it like this. So f prime let's not. Okay, so let's let's actually write it this way. Darn it. Okay, so dy dx. Okay, so that would be, so I have negative x, so negative 3. And now divided by negative 4. So I get negative 4 here. Right, so what I'm doing, I'm just essentially, right, plugging in. So 3 goes here, and negative 4 goes here. Right, so we get 3/4. And let's draw that circle, and let's put that point on the graph and see how it looks. Okay, so we have a circle with the radius of 5. Okay, so let's say this is 5, negative 5, and here's the circle. Okay, it's not perfect, but let's leave it this way. So the point, what was the point? The point was 3, negative 4. So 3, negative 4, 3, negative 4 would be, say it's here, right? So here's that tangent line. I wonder if I can move it. Let me try to move it. Let's see. Okay. No. Maybe like this. Oh yeah. Okay, so we have that tangent line. Okay, the point here is 3, negative 4. And then we could pretty easily find the whole equation. We found the slope. The slope was 3/4. And right, it worked. Looks right. Positive slope. Okay. Okay, so we could find derivative at any point, right? So we could do, let's say, at 3/4. Right, so at 3/4, same thing, right? I would plug in that that 3 and 4. The formula was something like this. So y prime equals negative x over y. Negative x over y, so we get negative 3/4. Okay, so yeah, 3,4 would be here somewhere. And then again, right, we could do, we have the tangent line. Okay, something like this. And yeah, you see, right, what the slope is negative, right, negative 3/4. Negative 3/4. Okay, I don't know, another point, right, could be maybe this point, right, so at 0,5. And you see what's going to happen, right? So at 0,5, tangent line will be horizontal. Slope is 0. So I'm going to leave it as yellow. So y prime would be 0 over 5. So you see that the slope is 0. Okay, so yeah, let's do another example. So example 5, I think. And so find the equation for y prime. Prime given okay, so we have an equation, implicitly defined function plus xy equals 7 minus y squared. Okay, so you can also try this by yourself, right? At least try to find the derivative of that. And yeah, I'll show you how to find that equation for y prime. And it's not difficult. Anyway, so first thing we're doing, right, we're taking derivative. So let me write it actually this way. So dx, right, of that first term plus ddx of the second term. So xy, and here I'm just going to take the derivative. So derivative of 7 is 0 minus derivative of y squared, dx of y squared. Okay, so first one is easy, right? So it's just 3x squared. The second one, again, we have x multiplied by y, so I need to use the product rule. So derivative of x, right? So that's just 1. And then times the second function, the second factor unchanged, plus first function unchanged, derivative of y, so that's just 1. So times 1 times derivative of that inside, so dy dx. And on the right side is 2y. And then dy dx. Okay, so I hope you understand that second derivative, right? So this one, derivative of y squared, right? So that's just treating that y as a regular variable. So that's 2y. Now multiplying it by derivative of that inside. Okay, so let me rewrite it. Maybe I'll use y prime for the dy dx, just to make the notation a little easier. So 3x squared. Now we have plus y plus x y prime equals 2y y prime. Okay, so yeah, what we need to do is we need to find an equation for y prime. If I can keep it here, I don't know. I'm sure I can. Anyway, so we're solving for y prime, and I have that y prime in two terms. So isolate those terms on one side and put the other terms on the other side. So we'll have x y prime minus 2y y prime. And I'm putting the rest of the terms, right? So terms that don't have y prime, right? So there's this term and this term, right? So there are two terms without y prime, so I put them on the other side. So that'll be negative 3x squared plus y. Okay, next step would be factoring that y prime out. Okay, so I'll factor it out. So I get y prime times x minus 2y. Okay, and then the right side. And the right side doesn't change, stays the same. I see that there's a mistake. This should be minus. Okay, moving y to the other side. Yeah, changing the sign. Anyway, so we have negative 3x squared minus y. And the next step is, right, I'm dividing by, I'm not going to write it, right? I'm just going to show you. So x minus 2y, right? Both sides by the same thing. Okay, just solving for that y prime. Okay, so y prime equals negative 3x squared minus y divided by x minus 2y. Would factor that negative out, right? So negative, if we factor negative from the top and put it to the bottom, I get 3x squared plus y. And the bottom will be 2y minus x. Right, so I factor that minus here, right? Minus, and then put that minus here. And change the sign at the bottom, right? So 2y ended up being positive, and x ended up being negative. Right, so that's the final answer. Okay, so that's the formula for right, to find the derivative at any point. Let me write it actually. So this, so formula for finding derivative at any point on the graph. Right, and that's the same as slope, right? Slope of tangent line. Okay, slope of line that's tangent to a graph, right? That we could find it at any point. Okay. Okay, so I just noticed a mistake. I was comparing comparing the final answer to my notes. Yeah, so the mistake is here, right? So it should be, right, when I'm taking derivative here, right, that negative doesn't disappear, right? So it needs to be there. So there's a negative here. Okay, then negative here. Okay, then we have this actually is positive. Okay, and then, yeah. And then the final answer, what I have in my notes, yeah, so it's kind of the top is the same and the bottom as a negative right there. So I hope you guys got the same thing. I hope it's right. Let's move on. So example 6. Okay, something like this. So an equation that I need to take a derivative of and then solve it for. So again, right, so solve it or find find derivative. Let me actually write it properly. So find derivative and solve for y prime. Okay, and the equation looks like this. So sine of y equals x. So this is actually in, right? So normally the this function, right? This is sine function. Normally it would look like this: y equals sine x. Okay, but this what we have here is actually an inverse of sine. Right, so we'd be asking what. So it would be plugging in, right, values of the function, of the sine function here, like half, right, and be asking, well, what is the angle? Right, so normally it would be written like something like this. So y equals sine, and then it will be this negative 1, right? Be like this or like this. Okay, but just for our purposes, right, I wrote it this way, right? So I kept y as I kept this y as y, right? I didn't change it to this notation, just so that we can, right, see how that implicit differentiation works here in this case. Okay, so yeah, so let's take a derivative of both sides, and let me write it. So dx of sine of y on the left side, and on the right side, and we don't need this. On the right side, similarly, dx of x. Okay, so yeah, right side is easy. Left side, maybe let me write that right side first. Right? So derivative of x is just 1. I don't know. I always struggle with this. Wish somebody could show me how to how to do it properly. Anyway, yeah, so we have on the left side, right, I have this sine of y. So derivative of the outside is sine, so it's just cosine, right? So I write cosine y. But now I need to have a derivative of that inside, so that's just y prime. Okay, so now solving for y prime, right? So I have 1 over cosine y, right, divided by cosine y, cosine y. Okay, so yeah, we did it, we solved it, but yeah, I think we can do better than that. So let's use right, I hope you remember this fundamental trigonometric identity. So sine square, in this case that should be it should be x, but I'm going to write y plus cosine square y. So that's 1. And I need to replace cosine, so I'm going to write cosine y. Right, so it would be square root of 1 minus sine square y. Okay, so let's replace that cosine y with that square root. So y prime, and we have 1 over square root of 1 minus sine square y. Okay, so we have that, and yeah, we can do maybe even better, because right now, right, I have this sine square y, and I know what sine y is, right? So I can replace that sine square y with x squared. So that will be equal to 1, and here we have 1. This is 1. Okay, 1 minus x squared. Okay, and this is I don't know. it's quite interesting, right? That you have we started with the trigonometric function, right? And derivative of that is actually a function that doesn't have any trigonometric ratios functions in it. Right? It's quite interesting. Okay, yeah. So that's basically the end of that section. Let me give you a bunch of practice problems. You guys can work on those. So practice or problems. Okay, so the first one. So the first one, or actually the first couple problems, is find y prime, right? So you need to solve for the dy dx or y prime using implicit differentiation by implicit differentiation. This is supposed to be n differentiation. Okay, so the first example looks like this. So x cubed minus xy equals 7 minus y squared. Okay, so pretty similar to what we've done before. The second problem is like this. So y equals sine x times y. Okay. Okay, and then problem number 3. So this one is a little different, but right, the idea is similar. Find slope of a tangent line at point 2, comma 2 given equation looks like this. So it's 4 minus x times y square equals x cubed. Okay, and the last problem, let me see, problem number 4 is like this. So we need to find y double prime for y square equals x cubed. Okay, so yeah, so solve those problems, try to solve them, work on them, and yeah, let me give you the answers. So let's start with number 4, right? So the answer for number 4, y double prime. Okay, so it's 6x 2y. 6x times 2y minus 9x to the 4th. And the bottom is 4y to the 3rd. Okay, so that's an answer for number 4. Answer for number 3 is 2. So n equals 2. Then number 2, let me see. Number 2. Okay, so number 2, so that y prime okay, so it's cosine xy. Right, so that xy is under the cosine and then times x. Times y. Okay, and then the bottom is 1 minus x. So we could put that y, be, I don't know, more elegant if that y was there, more easier to understand, and then x cosine xy. So that's number 2, and number 1 is y prime equals y minus 3x squared, and the bottom is 2y minus x. Okay, so you have the answers, so I hope you get the same answers. Yeah, there can be some variations, right, in this, how those answers are written. Anyway, so this is the end of 3.8, and the next thing we'll do is related rates. So that's gonna be quite difficult. That's, in my opinion, one of the most difficult topics in Calculus 1. Anyway, yeah, so that's the end of 3.8.